The problem based on operations of CT signal. So the next problem is sketch signal R of t into u of 2 minus t. So we can write this signal R of t into u of 2 minus t is equal to R of t into u of minus t plus 2. So we have to draw the R of t is the ramp signal. Okay, so here R of t is the ramp signal and u of minus t is the folded signal of u of t. So and u of minus t plus 2 is the delayed version or the delay of the folded unit step by 2 position. So first we draw u of minus t signal. This is u of minus t. It is 1 here for 0 and for all other as it is minus, it is a folded version up to the infinity, up to minus infinity. Next is delay by 2, delay by 2. So delay by 2 is u of minus t plus 2. So here we have to shift the signal towards right side by 2 and R of t is the ramp signal. So multiplication of R of t and u of minus t plus 1. So it is delay by 2. We can draw this signal as it is t, it is u of minus t plus 2, it is 0, 1 and it is next one. So from here we have to draw this 1 signal, okay, up to the minus infinity, and we have to draw R of t signal. This is t, R of t. So it is 0, 1, 2 and it is 1 and 2. So this is R of t signal and we have to take the multiplication of these two signals. So we get this is t, 0, 1 and 2. The next problem is, so next problem is determine the following system is time invariant or not. Yn equal to xn into x of n minus 1. So the first step is step 1 is delay the input by k, right here, delay input by k samples and denote corresponding output by y of n comma k. Therefore y of n comma k is equal to x of n minus k minus x n minus k minus 1. Question mark. Now next is step 2. Replace n by n minus k throughout given equation. So y of n minus k is equal to x of n minus k minus x of n minus k minus 1. This is equation 2. Now next is step 3. Compare 1 and 2. Step 3 is compare equation 1 and 2. So y of n comma k is equal to y of n minus k. So the system is time invariant. Therefore system is time invariant. Next problem, determine whether the system is time invariant or variant. So the problem is t of x of t is equal to a x of t plus 6. We have to find whether the system is variant or invariant. So the solution for this is the given expression we can write this given equation as y of t is equal to ax of t plus 6. Now the step 1 is delay input by k samples and denote this output by y of t comma k. So y of t comma k is equal to ax of t minus k plus 6. This is equation 1. Next is step 2. Step 2 is replace n by n minus k throughout the equation. So we can write y of t minus k is equal to ax of t minus k plus 6. This is equation 2. Now compare equation 1 and 2. This is step 3. Now next is step 3. Compare equation 1 and 2. So y of tk is equal to y of t minus k. Thus the system is time invariant. So the system is time invariant. Next problem, similar problem, determine whether the system is determine whether the following system is time invariant or not. So the problem for this is y of t is equal to cos of x of t. So this is the problem, and we have to find whether the system is variant or time invariant or not. So in that, step 1, delay the input by k units and denote this output by y of t comma k. So y of t comma k is equal to cos of x of t minus k. This is equation number 1. Next is step 2. Replace n by n minus k throughout the equation. So y of t minus k is equal to cos of x of t minus k. So this is equation number 2. Now next is step 3. Step 3 is compare equation 1 and 2. Compare equation 1 and 2. Now since y of n comma k is equal to y of n minus k, the system is time invariant. System is time invariant. Next problem. Determine whether the system is time invariant or not. The problem is yn is equal to mod of x of n. So step 1, delay input by k samples and denote this output by y of n comma k. So y of n comma k is equal to mod of x of n minus k. This is equation 1. Next is step 2. Replace n by n minus k throughout the equation. Therefore y of n minus k is equal to mod of x of n minus k. This is equation 2. Now we have to compare equation 1 and 2. Now next is step 3. Compare equation 1 and 2. Since y of n comma k is equal to y of n minus k, thus system is time invariant. Now next problem, yn is equal to x of. Now the problem is that we have to show here that these systems are time varying system. It is yn is equal to n into x of n. So first step is step 1, delay input. Same, delay input by k units and denote this output by y of n comma k. So y of n k is equal to n into x of n minus k. Next, step 2, replace n by n minus k throughout the equation. Therefore y of n minus k is equal to n minus k into x of n minus k. Now next is step 3. Since y of n comma k not equal to y of n minus k, this system is time variant. Okay. So the previous problem was like time invariant system. This problem is like time variant system. So similarly show this system also that it is time varying system. The problem is yn is equal to n into x square of n. So here also step 1, delay input by k units and denote this output by y of nk. So y of n comma k is equal to n of x of n minus k square. Step 2 is replace n by n minus k throughout the equation. So y of n minus k is equal to n minus k x square into n minus k. And next is step 3. So step 3 is, since y of n k not equal to y of n minus k, system is time variant. System is time variant.